Hello again and welcome to another quick video. Today I want to show you something I call refactoring one line at a time. Last week I was at the Socrates conference, I have a t-shirt on, and in the evening we were doing a mob refactoring session, so we were refactoring some code together. Something started to bug me because we were doing a pretty complicated refactoring. We were like introducing a class to wrap some primitive types. But the thing that bugged me was we were refactoring for 15 minutes already, and code was not compiling for those entire 15 minutes. So we were in a broken state, in a red state, what you want to call it, for 15 minutes. And that irked me. I was thinking like, could we do better? Could we like do this refactoring in smaller steps, safer steps, so we can get faster feedback than those 15 minutes? And turns out we can, so that's what I want to show you today. Quick recap, what do we mean with refactoring? A refactoring is a change made to the internal structure of software. Like you change the structure, you maintain the current behavior so that you can add a new feature or you can clean things up. It's also a verb refactoring. And refactoring, like I'm refactoring, what does it mean? It means I'm restructuring the software, so I'm applying refactorings. Cool. The problem we were working on was called code smells kata, and it's on GitHub. I'll put the link in the show notes below. But it's basically tic-tac-toe, but a very smelly implementation of tic-tac-toe. So this is the GitHub repository, and it's kata specifically designed to like work on code smells. So this kata contains all the smells you see here. Something else I want to point your attention to is called the Industrial Logic Smells to Refactorings cheat sheet, or I don't know what they call it exactly, the quick reference guide. And this is a super valuable resource because it maps code smells to the refactorings you can use to fix those code smells. For example, if you have alternative classes with different interfaces, what does that mean? This like some explanation in here, or links to the Martin Fowler books and another book. I don't remember which one this is. Is it the Krajewski book? Yeah, the Refactoring to Patterns book. But never mind. So you have code smells and a short explanation, and they map to like refactorings you can use to fix it. We're going to be using this today as well. So we have the code and we have a list of smells to refactorings. What are we going to do? Well, the refactoring we were doing this weekend that was going so badly was to fix a data clump or a primitive obsession smell. And let's go back to the cheat sheet and see what we mean. Over here you have, no, that's data class. I'm looking for the data clump smell. There we go, data clumps. So data clumps are bunches of data that hang around together, and they really ought to be made into their own object. And this is what we'll be doing today. So the refactoring we're going to be using is called extract class. Yeah, more or less. I want to add one additional constraint because the thing that irked me was we were going in a broken state for 15 minutes. And I want to push this like into the other extreme. I want to keep working on the code by changing only one, not two, not three, but one line at a time. And after every change, code should keep compiling and all the tests should keep green. They should stay green. This is a constraint I first learned about in this book. It's called 99 Bottles of OOP. It's written by Sandy Metz and Katrina Owen, and it's great. If you are into or want to learn about emergent design, OO design, refactoring, or like the really small steps we're going to take today, this book is a really good resource for that. Nope, let's not go there. If you have some time right now, I would suggest you try to do this refactoring yourself. So let's quickly go into the code and I can show you what I'm going to do. This is the tic-tac-toe code smells code base. And what do we have? Basically, we have a game and players can play. So we have player X and player O, and they play in turns. For example, first player X, he places his X on x0, y0, so on the 0, 0 coordinate. And then O takes a turn, he places O on 1, 0, and play continues until someone has 3 in a row, and X in this example has 3 X's in the top row, so he is declared the winner. So this is the game we're playing, and this is the code base. The smelly part we want to fix is the XY, oh sorry, was on the top here. So this XY, it's the location of a tile, but it's primitive obsession. It's like just 2 ints, and they are like used together all the time, but they are not together. And we want to wrap a new class, a new type around this. So if you have some time, please try out this refactoring yourself by changing only 1 line at a time. Welcome back, or in case you can't be bothered to try it out yourself, good to see you're still here. Let's do this. I want to show some helpful links to get started. And the refactoring technique I'm going to use today is called parallel change, or expand migrate contract. It's the same thing. Let's go to the blog post really quick to show you what we're going to do. Whenever you're like refactoring code and it's a breaking change, if you go back to the code, you'll see like there's methods with those x and y as arguments, and we want to like only use change 1 line at a time. So we're gonna have to do this breaking change 1 line at a time and keeping all the rest of the code working. Parallel change is a great refactoring technique in this case, and it has 3 steps. First step is write a new version of the code. So like if you have a method, write a new method with a changed signature and implement it. And next step is migrate all your consumers 1 by 1 for the old thing that you want to have gone to the new thing. So that's called the migrate phase. And in the end, when every client has migrated to the new version, you can delete the old method or whatever the old thing is, and you have successfully refactored. The book from Sandy Metz and Katrina also has this process, and they give you 4 steps, but basically the same. So you write new code, you make sure it compiles, and then you use this new code, and we're going to do this 1 line at a time thing, and at the end, when everything is migrated or refactored, we're going to delete the dead code. So same thing. Let's refactor. Let's go to the code. I have my code, I have my tests. My tests are green, and we are going to do something about this XY data clump. When I'm doing data clump refactorings or introducing wrapper types around stuff like this, what I love to do is first work on the setters, then work on the getters. Because if you first set the new data, you can use them, the initialized values in the gets. If you try to do it the other way around, you cannot take steps the smallest we're going to take, and you will have null pointers if you don't initialize your stuff right. So let's look where we're using these setters. And we see that the setter for the X property is used twice. Once when we initialize a new board, and once when we add a tile at a location, but this is dead code, so let's get rid of it and never hear from it again. So the setter is actually only used once. That's cool. And it's both X and Y are initialized to some values. Let's introduce the abstraction right on the tile. Why not? So location is new location with the X and Y coordinates we had. I'm gonna create a new type. I could have created the type first, so 1 line at a time is a very strict constraint. I'm gonna break it myself right now as well, so sorry for that. X, Y, so this thing takes 2 arguments, and this location type has to be created on the tile as well. So we're doing a refactoring, but actually we're like making the code worse. We have an X and a Y here, and now we have this new abstraction called location that will be implementing X and Y in a second. So right now it's just taking the arguments and crashing. I capitalized them, sorry. So this will never work, but okay, this will compile, will just be green because we're just like creating a new class. Forgot a comma, there we go. So this is not doing very much interesting. No, it's not, but it's compiling, it's green, everything's great. Let's introduce some read-only fields for this. I'm gonna make this an immutable class. I'm gonna make the getter public for now. So might be we don't even need this public keyword, but let's keep it public for now. Okay, so now we're just initializing a location with x and y whenever we are initializing the x or the y. Cool. That's the setter part for both those things. So they're only used here, and wherever we set this x and y, we're also setting a new location. So whenever x and y are initialized, our new location abstraction is also initialized on the tile. Great. Let's look at the getters now. I'm just gonna take the first one because it doesn't really matter in which order we're tackling this. And this is the first time we're using x and y in a method called tileAdd, and we're getting some coordinates again. So I'm looking into the future and I'm seeing this and I'm thinking maybe we should take in a location instead of an x and a y. But that's the next step. Let's first focus on this line. And what is this line doing? It is iterating over a list of tiles, and it's taking the single tile that has the exact same location as what we've been given right here. So this check, like checking if the x and y are the same, sounds a whole lot like behavior the location should know, right? So I can do the mechanical refactoring right here, so this should stay working. Yeah, it's still working. So we could stop here and move on to the next one, but I don't like this. This is this x and y thingy. This like checking if they're the same. This feels like behavior of the location. It's the only purpose of location right now. So let's go to the location type. Why is my resharper now? Okay. And let's introduce an equality right here. So let's implement equality members and let them use x and y. Sure. There we go. That's a lot of methods. Let's close them up and never look again. But now we have an equals that takes another location. Or we have an equals method and it like compares x and y. We only added new code again. We have not broken anything. At least I hope we have not broken anything. There we go. We were working on the first usage of the getter right here. And we made the move to the new thing, but I want to move it one level up, or I want to make it like a bit better and compare the location itself with what we've been given as an argument. So still single line change. And in the future I can see ourselves like pushing this thing up the call stack. So now we're pushing in an x and a y, and maybe in the future we want to push up take in a location. So let's work towards that. Whoa, extract variable was not doing what I thought it would. So location. Let's extract that into a variable first. There we go. And I'm taking a mental note like to do push up the call stack. We don't want to be working with x's and y's in this method. We just want to be talking the language of locations. But this would take us a bit too far from what we're doing right now, because right now we are tackling all the getters and setters of these primitive types. Add tile add also does the dot single. It's the same as this one. It's literally the same. So I'm just gonna even clean this up in another way. I'm just gonna use the method, forward this, and you'll see this is an X and a Y as well, so when we do the refactoring of this, it'll ripple up here. We'll also fix this. Everything is green, cool. Do we still have getters for X? No. Do we still have getters for Y? No. So let's not initialize these anymore. These can go. Kablamo. Everything is green, everything is compiling. Yep. And let's just get rid of these fields now. There we go. Everything is compiling, everything is green. Pretty sure this does not have to be public anymore. So now, like, the fact that we're working in 2 dimensions is starting to get encapsulated in this location class. Okay, yeah, MyResharp is telling me there's some naming conventions for private, so let's fix that. Technically, this is not one line at a time, we know, but I don't want to bore you to death either. There we go. So now a tile has a symbol and a location. X and Y has like been hidden away into the location abstraction. And maybe we can continue working on our to-do we just introduced. So this method is taking an X and a Y parameter, and we want to have it taking a location instead. So let's go and figure out where this is being used. Whew! 26 items. So this is a biggie. If you want to introduce, if you want to change the function signature so it takes a location instead of an X and a Y, you're in for the wild ride, right? So this is where the parallel change refactoring can come in really handy. And how does it work? Well, you just copy paste. So we're in the expand phase. We copy paste the method we want to change the signature of. There we go. And instead of getting in an X and a Y, we get in a location argument. So we now have a new function that takes a location and it performs the same behavior as this one up there. And because it's like that obvious how X, Y, and location are related, we can just call the new method. The method I'm changing right now, it'll disappear in a second. Oh, you know what? Yeah, you know what? I think we can even like do this faster. I'm gonna show you like 1 or 2 steps how we can migrate one step at a time, and then I'm gonna show you a cool trick to do this. Bam, big bang. But now we have 2 tile add methods, one with the old XY and one with the location. Let's find the usages of this old one. And there we go. We have an add tile add method and it uses the same. Again, I'm going to put a to do here. To do data clump fix data clump smell. So here as well we have X and Y and we want to have a location set, but this is not a refactoring we're doing right now. So I'm taking a mental note or like a code comment note of it, and I'm continuing. So this is the old method, it's taking 2 arguments, and instead we want to call the new method that takes location. And we see this, like this could bubble up really nicely as well, so I'm going to extract it already, and this location can go up in a second. And as you see, I'm changing the tile add colors 1 at a time, so this is really gradual. You can keep everything green and everything working. There we go. Tile add, sorry, I was getting a bit lost there. So we're fixing this tile add. We can do this for all the other 25 now. Yeah, we can do this for all the 25 call sites of tile add, or, cool trick, I'm hoping this works. Maybe we can inline this method. Yeah, so we can inline the old method. No, let's first go to one of those call sites. So on line 101, we're calling it, and it's providing me an X and a Y, and then checking if the symbol is like the empty thing, but okay. So at line 101, this is what the code looks like. Now I'm gonna do the 25 other ones in one go by inlining this old method that's calling the new method. And I'm just gonna bam, inline in all 25 call sites. And if we go back to line 101, it inlined it correctly because now we're providing a location. So boom. This is not one line at a time, but when my IDE can help me, I don't really care that much. It's as fast as changing one at a time. So what's the next bit we can fix about this data clump smell? Here we go. Our previous comments still stands. We're providing X and Y, and I would rather it have location instead. So let's see where we use this. Oh, only one place, cool. I'm going to show you another technique, somewhat similar to copy pasting the method and migrating as we did the tile add, but now on an argument level instead of on a method level. What do I mean by that? Well, I think this technique, I saw it from the 99 bottles of Oepe book. So if you want to do a gradual migration, it's only one color, so it's a bit silly, but I'm still gonna do it. If you want to do a gradual migration and you don't want to copy paste the method, you can do it another way, and that's by providing a new argument. So for example, location, but providing a default like this. I'm just gonna call it something location2. So I have a new argument, but it has a crappy default. Let's see if I can do this. No, so yeah, makes sense. So we have a new argument and it's null. And now we can do something cool at all the call sites, but for again, there's only one call site here, so it's a bit stupid. Now we can provide this new argument. No, you know what? Forget it. I'm gonna pretend like we have this. Pretend there's like 20 calls to add tile add. So now we have a nullable argument, so all the call sites should keep working, and location2 in this method should like be defaulted to null. How can you use this? Well, if you can say like, okay, location is whatever we get, or if that's null, build that location from what we're getting right now. So this nullable argument together with like this line of intelligent toggling between the features, it's like some kind of feature toggle even, yeah. We decide like which part of the code to use, like the provided location, or if there's no location provided yet, we can build it ourselves. I'm just gonna inline this now for a second, and I'm gonna rename this because it's bothering me. So there we go. Everything works, and now again in theory we can change every color out there, but there's only a single color, so this was a bit stupid, but again, it's an example, right? So we provide this new argument, it's not null anymore, so we're using the thing we provide instead. That was the last color, so we can remove this null default. It should still keep working, right? Yep. Now we're in a better place, but still not the best place because we have X and Y, and I want to get rid of that. So let's refactor. Change signature, Control S, Control R. I forgot. So I want to get rid of the X and Y. So let's just remove them. And this default we have in there did not work. If I did it in the other way around, like first remove the default and then change my signature, I would have done it in one line at a time. So again, I'm breaking my own constraints again. There we go. This is cleaning up nicely. So, where are we done? Do we still need to do something? So the only place where we know about X and Y is where we create our location and in the location type itself, I'm hoping. Yep. Oh yeah, that's when we build the location. It's bugging me a bit. We have this huge game loop. It's called play. And we have some duplication here. Like we have this new location XY all over the place. So let's extract the variable. Let's call that location, sure. Oh, yeah, and we have a lot of location stuff. Okay, it's already using the new abstraction, so I'm not gonna bother too much with it. It's okay. It's okay, it's okay, it's okay. It's okay, it's okay, it's okay. All good. Cool. I don't think we use X and Y anywhere else except here in this huge play method. Yeah. So again, we can introduce this nullable argument and start moving one by one, or I think we can use the extract method, inline method hack we used a while ago. So let's use that one, because it's a bit more elegant. Let's extract everything. No, I'm gonna explain what I'm doing first. This play method, so it still has data clumps X and Y int as input, and we want to move like the API to accept a location instead. And the first thing we do in this, let's move this window, there we go. The first thing we do in this method is create a location type based on the X and Y. So everything below works on this new location abstraction. It does not actually need the X and Y anymore. So let's extract a method, and this method takes the location, yep, and let's call this play whatever, foo change me, so we don't forget to change this. There we go. So now we have a method that takes a symbol and takes a location, so that's better than symbol and XY. Let's make it public. Why, you ask? Well, because now in the old method, or no, I'm gonna do it like, show you the example of what I could do step by step, line by line, and then I'm gonna do the big bang again. So now we have a play method, and we have migrated the second implementation that's taking in a location. So let's find the usages of this play. And this is one place where we use it. So it's putting in x0, y0. You know what? It's different types, so I can just overload the play method name. I don't know why I did that, sorry. And instead of providing x0, y0, let's call that new method with a location instead. Again, only changing one line of code. And run it. Should still be green. Boom. Cool. And I could do this. Whoa, how many usages did it have? I can do this 40 times something. Yeah, I can do this 40 times more. Or if you're bored, you can just do the hack or the trick I did before, the old method. I'm gonna inline everything. So play similar new location. And I'm gonna inline this entire method. So those 40 call sites, kabam! They're now just all calling this new method instead. Let's take a look. Yeah, looks good. Let's see if all the tests work. But again, I could have done this one line at a time. Especially if you're working in a realistic code base, you're working with multiple teams. This parallel change refactoring, where you just cannot have access to all the consumer code, this one line at a time thing can really help you out by performing huge redesigns or huge API refactorings or redesigns incrementally and one project or one color at a time. So for this example, it's a bit much, so it's a bit exaggerated, but this technique is super useful if you're going cross-team, cross-service, cross-application, cross-project, whatever boundaries. Okay, we fixed our play method signature. It's getting a location instead. Great. Yeah, there's these hard-coded XYs, but I don't think I'm gonna fix that today. It's working with a new location abstraction, so it's not the end of the world. Let's keep that. Yeah, let's keep that. I think we are done with the location refactoring. Let me go over the tests real quick. They're all speaking the language of locations. Yep, they are. I'm done. Everything is green. And we change it one line at a time, ish, I guess. So there we go. This was parallel change refactoring, and refactoring the data clump smell by extracting a new class or introducing a new class. And we did this by changing one line at a time. If you want to try this out yourself, this tic-tac-toe game still has one primitive obsession smell left, or maybe more, but one I see right now for at least, is this symbol thing. It's a character, and characters are primitive types. So the code smell, no, this is the one I was going for. There's a code smell called primitive obsession, like when you depend on primitives like strings, ints, or chars in this example. You can apply some refactorings, and I urge you to try the one line at a time refactoring technique, so the parallel change refactoring, on this symbol thing. So try to fix the smell, but try it by changing only one line at a time. I'm gonna quickly recap what we did, and I'm gonna let you go. So I introduced you to the parallel change refactoring, allowing you to make sweeping breaking API changes one line at a time, so very gradually. Everything keeps working, everything keeps compiling, every test is still green. The 3 steps in this parallel change refactoring are expand, so copy paste the thing or add a new argument, whatever, and then migrate one by one, call side by call side, migrate from the old thing to the new thing. And once you're done and the old thing is not being used anymore, you can do the contract phase, which is basically delete the old thing. Cool. I showed you 2 flavors of this. One was with the copy paste of the method to the method, a new method with a changed signature. And the other one I did was you had a method with some arguments, and I bumped a new argument there that was like had a null value as a default, so it wouldn't break existing callers, and then some feature toggling inside it. So those are 2 flavors I know of to perform parallel change refactorings. We also did the smallest changes possible, or that was at least the theory. So we tried changing only a single line at a time. Do I do this for daily work? Heck no, but it's good to have practiced this in case you would need it in the future. I take bigger steps, but when those big steps starts failing me, I know how to fall back into these really small, really safe steps. And finally, I want to give you a big recommendation for this book, 99 Bottles of OOP, because it's the book that introduced me to this micro refactoring style, and I absolutely love it. So there you go. I hope you learned something, and happy refactoring.